gigabytes, but Germany is 837. We thought what we could do with it and found that there is a lot of details, a lot of each, I don't know, maybe each tree in woods, but it's mapped very well. And France is even more details. Second core goal was style summer. We thought it will be quite great to apply styles to our map, so it's not predefined, it's very flexible, and you will decide what kind of text, what kind of polygons or lines you want to see on the map on currency level, and it's our implementation of map CSS. It's a subset of map CSS syntax, but it's pretty complete. And our third goal was to use GPU for rendering. It's a major goal, and because in another applications, in other versions of render is mostly used to render from CPU and render to just texture. And when you switch between those textures, you need to render one more tile or one more part of the screen, and GPU will handle it very flawlessly because the data is already loaded on GPU and it will be scaled or up and down without re-rendering. It's basically rendered 60 times per second and 4 seconds. So that's what's okay to have some goals, but there was problems relative to it. We needed to write our own map extractor to prepare data for these formats suitable for rendering, and it was quite difficult to parse map CSS and apply it on right and twice, because there is not only fill color, there is only width for lines, and sometimes rules depends on eval values, and you have to calculate code that code should look like based on some tags and perform some math, and its performance will like right and device. And format is data loaded from produced by map CSS parsing. It should be perfectly fit for loading to GPU. Okay, I'll tell you a bit reasons, because each time you add some rules into your map CSS file, you had to think, oh, did I include that information in my filter file? And that was kind of a headache. So we write it that's query generation right from map CSS file. Extractor tool reads general map CSS file, which could have more data than we actually render, but rules from that base map CSS file use it to produce queries for database and to filter objects in database results. It's very, very useful. We saved around 30% after that improvement, switching between handmade filter files and filter and write from CSS. And our invention, I want to say, is merging information. So we thought of it to save information not for each zoom level, as you mentioned, and used few zoom levels saved in one bounds. For example, for 5 zoom level tile, we save information that under it from 6, 7, and 8 zoom levels. It's contain all information that will be displayed on 6, 7, and 8 zoom level inside one tile. So we just skip those zoom levels, and after 5 it's 9, and after 9 it's 13. It's very useful because you don't need to load those tiles when you zoom in. You parse it once and you see that information right when you zoom in from 5 to 8, for example. Okay, and a few words about why we decided to choose GPU. Luckily, game developers and game players move market forward and ask for more powerful GPU each year. I collected a few data about performance growth for GPU for iPad first, second, third, plus generation 4. And as you can see, it moves from second to third 2 times, from third to fourth. Also, it grows 2 times, and it's very powerful. Between second to third generation, they had to make that performance increase because resolution also increases from 1024 and to twice. It's barely 2000 for 1000 count. And but between the third and fourth generation, it's just because games. So third generation works pretty well, but some developers write awesome games, and Apple decided to why don't put more powerful hardware in next generation of iPads. And with that growing, we hope next year or this year, iPad presented in September, October maybe, it will be even more faster. So we could draw great maps based on that hardware using that growth. And by nature, GPU is developed to draw a lot of similar data, and in maps it's a lot of similar data. As you can see on screenshot, there is all built in inside one tile, rendered using just one draw call command. We ask GPU draw information from that vertex array buffer. All buildings disappear. But is it that powerful? Like it's could be. There is very hard question because even most powerful GPU, I don't know, for desktop, it could be overloaded when you decide to render in real time some overmapped So, as you can see, we're just joining the data. It's combined together, well parsed, and displayed in GPU in one row call, as I showed before. Yeah, and that's why we try to remove unnecessary anti-aliasing, unnecessary texturing, and try to keep it as simple as possible. A bit about optimization, and let's keep it as simple as possible. Firstly, we try to draw beautifully crafted lines. It's designed, it's combined from triangles, as you can see. Texture is applied on top, and it looks really beautiful. But you can see how much data is produced from one line. Even it's simplified. There's a lot of triangles and a lot of work. So if you'll try to draw some block of the city with that approach, it will work very slowly because it will be overloaded by unnecessary raw triangles. It will be very beautiful, but very slow. So we decided to use just two simple GL line approach. It's just points and lines without texture, without anti-aliasing. We tell us our maps CSS parser to just use fast lines. Okay, and it produces line by points without triangles. It works really fast, and all small roads inside that tile is drawn by one draw code. No triangles. Okay, and now time for, oh, I forget that. So, in styles, you need to keep different uniforms. And first of it, obviously it's pixels. But on retina display, those pixel styles will look too small. So we added points to just multiply by 2 those styles to make it a little bigger and look identically on older iPad and iPad 3, 4, etc. Maybe they put super retina display and we had to multiply to 3 anytime, but I don't know. And last one is meters, obviously, because it's has zoom levels when your rod is wide enough to be drawn its real physical size. And if you know how much line it is, or you assume from that rod kind that it should be 3 lines per each direction, and line width is 3 meters. So you could write a rule that will reduce rod exactly what physical size you want. And a bit of kung fu from styles. Yeah, it looks a bit complicated, but that's how we try to optimize our CSS parser to produce as few as possible blocks with data. This function inside eval is linearly interpolates width between zoom levels, and that's width sent to shader right on GPU, and it scales one set of data. So you don't need to even generate new set of data between zoom levels. It's width applied on the fly. As you zoom in, rods become wider. And last section is that metric thing I mentioned before. We try to extract lane stack from that rod, and there's no lane stack. We assume that there's 3 lanes and 3 meters each of them, and round line cap to make beautifully switching from different widths. If some parts lanes is set and another not. And now, okay. And now I'll try to show you in real time how it works. want to see how it works?
Yes.
Okay. And I really like to show you how it works. So we proceed and do that. I don't know, maybe too small screen resolution for that iPad. We'll try to draw 100 and yeah, I'll switch from iPad directly. Oh, that's great. You have a lot of tools. Awesome. That's our render. And when we traveled to Tartu, we made small demo map of 4 countries: Belarus, Lithuania, Latvia, and Estonia. And as we used tile approach, it saved all tiles intersected on 5th zoom level. It's 5 tiles, or 4 tiles actually. And when you see this image, 6, 7, and 8 zoom levels are loaded also. So I'll zoom to top. As you can see, it's just switched between zoom levels and text remain in its place, and now rods and borders disappear. I hope it's simple. And we zoom in even more and more. Now we'll load 9 zoom levels with data of all small cities, all forests, all smaller roads, and those. Okay, there's loading. It's really fast. We tried many approaches to optimize it as, I don't know, everything. Every single thing that will be optimized, we optimize. So I hope you appreciate that. And with some more, immediately woods there. And there is all small cities around. Okay, that's roads and downtown. And we'll load 13 zoom level with all buildings information and all amenities, and its last zoom level is saved, and it's contained every detailed information, every amenity, and pedestrian roads, basically everything included in our style. So, building numbers disappear, and we actually tested our render how it works with text, because we discovered there is every building has its number in Tartu, and our render had problems with that many texts. Yeah, because in Minsk, when you see small buildings, mostly they haven't numbers. And I'll zoom to maximum zoom level and then zoom out, and you'll see what a mess is stored in GPU. It will flicker for
because it was, for me, it was quite a big problem to process it. And actually, I would rather nature laws where it's possible for overview of
managed
levels.
tried, I think, 3 or 4 times to do that and solve different kinds of problems sometimes because it's a style approach and you simply pay data, you had some corner fixed point removed and it's like arrow inside inside water or another side. So yes, that was hard, but we managed to do it from awesome data.
So it's a real-time render.
Yeah.
Is the data source is on the same, not on the line?
Yes, it's generated from awesome data. That data is, I think, a month ago.